So as far as a system goes, it's nice to start looking for your asymptotes. We're going to look if we can factor anything to see if our non-permissible value for A, which is x can't equal -2, we want to know if that is a vertical asymptote or a hole. So the first thing we're always looking for in our asymptotes, to start with the vertical one, look at our non-permissible values. We'd have to check by factoring the top factors to x plus 7, x minus 1 over x plus 2. Nothing simplifies, so we know that we have a horizontal asymptote at x equals 2. So I always start with my horizontal asymptotes. After I'm done my horizontal asymptotes, I'm going to look next for my vertical ones. Well, to find out if you have a vertical asymptote, you look at your highest power. Highest power in this one is x squared. I have 1x squared on the top, no x squareds on the bottom. This is not possible. So for vertical asymptotes, there is none. If you have no vertical asymptotes, that means you're going to have an oblique asymptote. To find our oblique asymptote, we're going to take our function and divide it. Since I'm dividing by x plus 2, synthetic division works better than long division. So I set it up. It's x squared plus 6x minus 7 divided by x plus 2. So I'll put a -2 there. Bring the 1 down, multiply, add, multiply, add. The remainder doesn't matter. Our oblique asymptote is x plus 4. And now we're ready to graph it. What do we know so far? We know that we have, whoops, I got my words mixed up, x equals 2 is our vertical asymptote, right? Then we checked our horizontal asymptote. Yep. And so we start with x equals -2 as our vertical asymptote. We have no horizontal asymptotes, but our oblique asymptote is a line, y equals x plus 4. How do you graph a line? Start with the y-intercept, and it has a slope of 1, up 1, over 1, or down 1, over 1, and draw your diagonal asymptote as well. Couple of things. Can you see that we factored this one? We factored it to x plus 7, x minus 1. What that tells us is if we wanted to make y equal to 0, we know what our x-intercepts are. They're going to be -7 and 1. So when I'm going to graph this, I know that I'm going to have an x-intercept at -7 and an x-intercept at 1. I now have a point to the left of x minus 2, and I have a point to the right of x minus 2. So as far as my graph goes, it's going to swoop towards, that's pretty bad actually. Whoa. I'm going to do that again. It's got to go through this point and then approach the asymptote. So it's going to go down towards my asymptote this way, and it's going to swoop up towards my asymptote that way. Again, if you want more points on your graph, you can use a table of values. Pick a value for x, find out what y is, and plug it in. Since I know it has -1 here, I know that it's going to go down towards my asymptote there and up towards my asymptote that way. And that would be a sketch of our graph. The only thing I haven't labeled on here yet, I forgot to label this asymptote on my graph, x plus 4. I should probably label something on my y-axis to give a scale for my y-axis, since both of my points were on the x-axis. And that's how you would graph this function. Again, you could get more points with a table of values. Some exam questions are such that the best thing to do in this unit is to use a table of values to find them out. So, we wrote all the equations. We didn't use graphing technology to do it because I'm showing you right away how to graph them without your calculator. And now we can look at the second one. So again, we're going to start with our asymptotes. We're going to start with our vertical asymptotes, which we can find by factoring the bottom factors to x plus 7, x minus 1. None of those factors cancel out, so we have no holes. We just have two non-permissible values. X can't equal -7 and x can't equal 1. And then from there we know that our vertical asymptotes are x equals -7 and x equals 1. Next we're going to check if there's horizontal or oblique asymptotes. The highest power in this one is an x squared. We have 1x squared on the bottom. We have no x squareds on the top. That simplifies to 0, so we'll have y equals 0 as a horizontal asymptote and no oblique asymptotes. And so now for this one, if you were going to graph it, start with your asymptotes at x equals -7 and x equals 1 and y equals 0. What you're going to do is you're going to find, is it easy for me to find my x-intercepts? Can I find x-intercepts quickly? Well, when I factor a function, how do you find an x-intercept? You make y equal to 0. And if y were equal to 0, and this is a big fraction here, the only way a fraction's equal to 0 is if the numerator is equal to 0. So we're really only looking at the top part here. What would make the top equal to 0? -2. So on my graph, I know that -2 is an x-intercept. That's on our horizontal asymptote. That's okay, because our horizontal asymptote is showing us what's happening when x is getting to really big positive numbers or really big negative numbers. It's not really a non-permissible value for y. It's just telling us what happens when x gets really big or really small. Now to find out the rest of the graph, we're going to need to find out what's happening when x is less than -7. What's happening when x is in between -7 and 1? And what's happening when x is bigger than 1? So we're going to plug in some values. A number really close to -7 would be -8. Can you see when you plug in -8, you'd get -6 on the top. You'd get -1 in that bracket. And -9 in that bracket. If you simplify that, you're going to get -2/3. -8, -2/3. What does that mean by having it in this section? It's got to approach both of those asymptotes. That's the shape in that section. Between -7 and 1, I'm going to want to plug in some values on both sides of -2, because that's where it's touching the asymptote. Because it might be swooping down this way or swooping up that way, and we're going to find out. A nice value to always graph is your y-intercept. How do you find a y-intercept? Plug in 0 for x. Plugging in 0 for x, you're going to get 2 over -7. 0, 2 over -7. That's going to be that point there, which is telling me this is going to be swooping down like that towards the asymptote. If I plug a value like -3 into my equation, -3 on the top would give me -1. -3 there would be 4. -3 there would be -4. That'll give me 1/16. So it looks a little bit like an x cubed graph in the middle. And finally, I'm going to find something bigger than x equals 1. Going too big sometimes gets the values really large, so I'm going to just try one bigger, plug in 2. What happens when I plug in 2? I'm going to get 4 on the top, 9 there, 1 there, just 4/9. 2, 4/9. And you just need one point in a section with asymptotes, and then you can draw your graph towards the asymptotes after that. So it's a really crazy looking graph, but we've got a sketch of its general shape as a result. Questions you can do for this are 6 and 7. Yes?